and section 2.2 is about solving absolute value equations. So we're going to lead off with a simple example. So let's say we want to solve the absolute value of x is equal to 5. What does that tell me about the value of x? What does x have to equal? Good. So there's negative 5 or positive 5. So I can get two solutions. What if I take the absolute value of x is equal to 0? What is x in that situation? It has to be 0. So I could get one solution. What if I add the absolute value of x equal to negative 5? What does x have to be in this situation? You can't have that, right? What's wrong with this? The absolute value always gives us a non-negative answer. There's no way for the absolute value to output a negative value to it. So there's three possibilities that we could run into when solving an absolute value equation. I can get two answers, I could get one answer, or I could get no answer to a given solving problem. So we're going to have to be a little bit careful with the procedure that we use to do this. So what I'm going to outline here is going to be the procedure that we're going to use to solve these absolute value equations so that we can make sure that we find the proper number of solutions. Yes, Tom. Procedure. So the first step in our procedure is to isolate the absolute value on one side of our equation. The next step is going to be to turn the absolute value equation into two linear equations. And again, we'll talk through the details of like how to do these steps in just a moment. Right now, I just want to kind of outline the general procedure, and then we'll worry about the details in the examples here momentarily. Step 3 is to solve each of the linear equations separately. And the fourth step is to check. So again, the idea here is we're going to isolate the absolute value equation, or absolute value. We're going to split the absolute value equation then into two linear equations. We'll solve each of those two linear equations separately, and then we'll check our answer, or answers. So let's look at some specific examples, and we'll walk through like how we go about accomplishing these steps. So let's say we ask to solve this equation for x. I'm going to do several examples. I'm going to letter them A, B, C, etc. So when I look at this, I see two things going on outside of the absolute value. I see this times negative 2, and I see this plus 5. Everybody agree with that? That there's two things going on outside the absolute value. In order for me to isolate the absolute value, I have to move those two things to the other side of the equation. Which one should I move first? The times negative 2 or the plus positive 5? The addition is the one I should take care of first. In order to move that 5 to the other side of the equation, what do I need to do? Subtract 5 from both sides. Yeah. So typically we want to undo the addition and subtraction before we deal with the multiplication and division. Everybody okay there? Now, to get rid of that times negative 2, what should I do? Divide both sides by negative 2. What is the alternative way of doing this? You could also, instead of dividing, you could multiply by the reciprocal, right? So if you could multiply both sides by negative 1/2, that's okay as well. When you have fractions, that particularly sometimes makes life a little bit easier to think about it that way. So we're now done with step 1. Right? We've isolated the absolute value. So one side of my equation is just the absolute value part. Does everybody see that? Okay. Step 2 then says to split this absolute value equation into two linear equations. So I like to draw these two little dashes to remind myself that that's what I'm doing. So the first equation is exactly the same as the absolute value equation, except I dropped the absolute values. So everything was the same except for the absolute values. Everybody okay there? The second equation, the absolute value side is going to be the same, but the other side of my equation, I make negative. Yes? Then it would become negative of a negative or positive. Yep. Good question. We'll see that in an example here coming shortly. Everybody good so far? That's step 2 done. Step 3 says to solve each of these equations separately. So let's solve the one on the left first. What would be the first thing I want to do to solve 3x minus 6 equals 2? Add 6 to both sides. Excellent. And then what would I do? Divide 3. Yep, divide by 3. Good. And we'll write our answer as 8/3. I don't need you to convert that to a decimal. I don't want you to. I don't need you to convert it into a mixed number. I don't want you to do that either. Improper fraction would be the preferred answer for any kind of solving problem. If it's a story problem or a graphing problem where the decimal is more practical or more meaningful, that's fine. But for a solve for x problem, your final answer should be written as an improper fraction if necessary. And then we'll solve the other equation. So just like before, we'll add 6 to both sides. Absolutely. And then divide both sides by 3 again, just like we did on the other one. And this time we get x is equal to 4/3. So we've solved each of the linear equations, so we finished step 3. The last step now is to check. So when I'm checking, I'm going to be plugging in my answers into the original equation And you'll notice that when I do this, I write a question mark over my equal sign because I don't know if these two things are equal. That's literally what I'm going to be checking, right? Okay, so what I'm going to do now is I'm just going to simplify these left-hand sides. So the order of operations says I should start inside the absolute value, and I would want to do the multiplication before the division. If I multiply 8/3 to 3, I get just an 8. If I do 8 minus 6, I get 2. If I take the absolute value of positive 2, I just get a regular 2. Negative 2 times 2 is negative 4. And negative 4 plus 5 is 1. So that works out. So what that tells us is the 8/3 is one of our answers. We'll do the same thing now for the 4/3. So 3 times 4/3 is 4. And then 4 minus 6 is negative 2. Absolute value of negative 2 is positive 2. Negative 2 times positive 2 is negative 4. And negative 4 plus 5 is 1. So that one checks out as well. So that tells me that 4/3 is also one of my answers. Now be careful on this step. It is possible that these do not work. One of them might not work, or both of them might not work. And it's not necessarily because you did anything wrong in one of your solving steps. This is a possibility when solving absolute value equations, is you get things that do not work. Do not skip the checking step. I know many of you are like, yo, I did this right, I don't need to check it. You do, because even if you did the solving right, your answer still might not be an actual real answer. Okay with that? Let's do some more examples, though. So let's solve the equation negative 5 times the absolute value of x plus 1 plus 2 is equal to 12. What should I do first here? The first step is to isolate the absolute value. So what do I want to do first in order to isolate that absolute value? Harlan? Subtract 2 is correct. So typically we want to undo the addition and subtraction before we do the multiplication and division. Okay. What should we do next? Divide by negative 5 is correct. Good job. That's going to give us x plus 1 equals negative 2. Now what should we do? Okay, split it into two linear equations. What will the first linear equation be? X plus 1 equals negative 2. And what should the second one be? X plus 1 equals positive 2. You could think about that as the negative of the negative, or you could just write positive. Either is fine. Okay? So we have our two linear equations. What should we do next? Yeah, solve each one of them. So we'll do that by subtracting 1 from both sides. I'll get negative 3. And subtract 1 from both sides, I'll get positive 1. So far, so good? Okay. Let's check now. Gotta remember to check. So if I check the negative 3, I simplify, negative 3 plus 1 is negative 2. The absolute value of negative 2 is positive 2. Negative 5 times 2 is negative 10. And negative 10 plus 2 is negative 8. And that's not equal to 12. So that tells me that x equals negative 3 is not one of my answers. And we have a special name for this. So when we find an answer in the solving process that's not a solution, and it's not a solution not because we made a mistake in our algebra, it's just not, it's like an extra solution. And that's where this word extraneous comes from. If you look at that word extraneous, the root word there appears to be extra. It's literally an extra solution. It's not an actual one of our necessary solutions. Okay? You just put an X through it like it's not actually, it doesn't work. I'm just giving you a name for what that's called. But you can just draw an X through it and cross it out. So we found it, but it doesn't actually work, so we'll cross it out. There's no mistake in our algebra, it just doesn't work. So let's check the other one now. So if I do the same kind of thing, I get, SpaghettiOs, negative 8 on the one side and 12 on the other. So that one doesn't work either. So this again is another extraneous solution. And since I've crossed off both of my possible answers, what would I say about this problem? Yeah, we'd say there's no solution. Okay. So here you're seeing that definitely that checking step matters, right? Because this extraneous solution thing can happen. Did anybody notice something about this problem earlier that would have allowed us to shortcut to this answer without having to do all this? Let me point out this step. What do we see here? I see an absolute value that's equal to a negative. Is it possible for an absolute value to give me a negative? No. Right here, you could have stopped and said no solution. Justin? Of course. So, now, being able to do that is relying on you noticing that you had an absolute value equal to a negative. Nobody here apparently noticed that as we were going through. Nobody spoke up, which is fine, because we caught the no solution part still at the end with the checking. But if you did not check, you would miss the no solution part, right? And you're going to get this question wrong because of that. So make sure that you are checking. I know that it's annoying. You don't have to write down your work for the checking like I've done here. You can just check it on your calculator or whatever. That's fine. But you do need to make sure that you are doing the checks, because it does matter. We'll do one more example and we'll call it a day. Sound good? I'm glad. You didn't have a choice. That's what we're doing. So, 3/5 times the absolute value of 2x minus 4 minus 3 equals negative 3. First thing I should do is add 3 to both sides, absolutely. Don't be afraid to shout them out when you know it. That's okay. All right, what's next? Great. You might have thought to yourself, I'll divide both sides by 3/5. That's the same as multiplying by the reciprocal. I usually like to write it as the multiplication of the reciprocal, but there's nothing wrong with writing as dividing it by a fraction, although it's a little bit neater to write it as multiplying by a reciprocal. Yes, Olivia? Yes. So when we multiply both sides, we have the absolute value equal to 0. If you recall from before, we identified when the absolute value is equal to 0, it's going to have one solution. So that's what Olivia is noticing here. If you didn't notice that, that's okay, because we'll pick it up, the one solution, in our solving process. If you didn't notice that, it's not a big deal. So we'll start by breaking this into two linear equations. The first one is 2x minus 4. What would the second one be? Yeah, 2x minus 4 equals negative 0. But what's negative 0? Just 0, right? So we have a duplicate, two of the same equation. I don't even need to worry about solving one of them. I only need to solve one of them. I don't need to solve the same thing twice. If the two equations are identical, which happens when we have the absolute value equal to 0, as Olivia pointed out. So when we do this, we get x equals 2. And then all we need to do is check. And it's nice here because we only have one thing to check, right? So a little bit less work than the previous ones. Okay, 2 times 2 is 4. 4 minus 4 is 0. This probably should put an equal sign there, or not, a question mark there. The absolute value of 0 is 0. 0 times anything is 0. And 0 minus 3 is negative 3. So that one does work. There's my one solution of x equals 2. What do you guys think? Not so bad, right? You can handle this. Typically, students feel a bit more comfortable doing the algebraic, the symbolic stuff than they do the graphing, at least early on. So for next time, I'd like you guys to do 15 through 16. So the directions in the textbook ask you to graph your solutions. I don't need you to do that. And I'd also, in addition, like you to do 23 and 24. So your assignment for next time is 5 through 16. Don't graph the solutions. And then 23 to 24. When they say graph the solutions, literally what they would mean if our solution was x equals 2, they mean for you to do this. I don't know why they want you to do that. I don't know what extra benefit that's going to give you by doing that. I don't need you to graph the solutions, because I don't think it really gives you any further insight about what's going on here. Just like a waste of your ink. Okay?